In 9.1b, we're going to interpret p-values in context and make conclusions. So by definition, what a p-value is a probability, and more specifically, it's a conditional probability. Here's what it is. What is the probability that the statistic that we got from our sample happened given that H sub O is true? So the formal definition would be this. It's the probability the statistic would take a value as extreme or as more extreme than the one actually observed given H sub O is true. Basically what it means, it's a probability in which we're measuring the strength against H sub O happening. I always like to refer to it as a conditional probability and interpret it from there. Because again, as conditional, it's saying, given that H sub O is true, what's the probability that our statistic or something more extreme happened? So in doing that, when you analyze it, the smaller the p-value you have, the greater the evidence against H sub O, because observed result is unlikely to occur when H sub O is true. Or another way to think of it is just go back to this probability statement here. A small p-value says, hey, the probability of that stat that we just got from our sample to happen, given that H sub O sub true, is so unlikely that it's not going to really happen. Therefore, we're going to go against H sub O and actually reject H sub O and say it's not true. Put it in a general context for a criminal trial example. Now, for a trial to even take place, there must be preliminary evidence of guilt. If there's not even preliminary evidence, they're not going to waste their time and actually even go through a trial. They're going to skip it. So therefore, when you define the hypothesis for this, H sub O is innocence, but you're going to court because we think you're guilty. Therefore, we're trying to prove or conclude that H sub A, which is guilt, is the true case. So then the trial goes on, and what that means is the jury actually needs to decide if the evidence is actually convincing enough to say we reject your innocence and we go and say that you're guilty. So basically, a jury is kind of thinking about their p-value. What's the probability of that crime happening? If it's so unlikely that it's going to happen, but it actually happened, they're probably going to reject your innocence and assume you're guilty. So another question to ask yourself is, when do you actually do a significance test? Well, you do it if a sample provides preliminary evidence that H sub O is actually true. Again, in the jury example, they're going to go before a judge first to see even if they can prepare to have a trial. So they're going to take a sample and see even if we should do a test in this case for H sub A. If you get clearance to do the test, then you go ahead and you determine if it's convincing. If it's convincing, what you're going to do is calculate the p-value and make a conclusion. Now, the conclusion you would make is if the p-value is small, means the probability of that stat happening, given H sub O is true, if it's small, there is convincing evidence in the favor of H sub A, since the plausibility of H sub O being true is so unlikely and so rare to happen. And if it's so unlikely and rare to happen, one might say that the value occurred by chance alone. Let's go back to our free throw shooter. So since our alternative hypothesis was that p is less than 0.8, the sample results counts as at least as extreme are those with a p-hat of less than 0.64. So what that means, the p-value is a conditional probability. What is the probability that our sample of 64% happened given the fact that the true proportion is 80%? Well, I will tell you it calculated out as 0.0075. So interpret that value in context. Well, recall again, this was a hypothesis if you want to see it. So in context, all I have to say is something like this. Given that the player makes 80% of his shots in the long run, the probability of him getting 64 or fewer, and we say or fewer because we're doing less than, the shots is 0.0075. And if this is stated as a percent, let's fix it. It should be the point right there, so 0.75%. Now, folks, that p-value is so unlikely. It's not even 1% chance to happen because this sample that we took was so unlikely to happen, but it did happen. we would actually end up coming back and rejecting the H sub O and concluding that H sub A is correct. And we'll talk more about that in a little bit. Our better golf one that we did before. Remember, Mike was testing his 7-iron. This was his hypothesis here. He thought the iron could get his variability down, so we thought standard deviation would be less than 15 was really the case. So based on 50 shots with the 7-iron, his actual standard deviation was 10.9. So a significance test using the sample data produced a p-value of 0.002. Interpret that in context. Fine, if you want to actually put the values in this conditional formula and say it, it might be easier to actually state. So one way we could say this is, if the true standard deviation is 15 yards, then there is an approximate probability of 0.002 that the sample standard deviation would be 10.9 yards or lower, because again, we are going on the less than side of random chance alone. So, by the way, right, that is a 0.2% probability of happening, which is so unlikely. Do the data provide convincing evidence against the null hypothesis? Because remember, that's why we're doing this. We think the null is wrong, and we think this is true. Well, the likelihood of our particular sample happening of the 10.9 yards is so unlikely that, yes, we're going to say, you know what, the null hypothesis, we're going to reject it, and we're going to conclude that H sub A is true. So based on that, yes, the p-value is very small. Random chance is not a plausible explanation for why the sample standard deviation was lower than 15 yards. Thus, this is convincing evidence that the true standard deviation with the new 7-iron is smaller. So ultimately, if we end up being able to say that we can reject H sub O, what you end up doing is you conclude that H sub A is the case, which is that the standard deviation is less than 15 or smaller. Back to the legal case. Again, remember, H sub O, you're coming in innocent, but you're on trial because we think you are guilty. So in this case, if we reject H sub O, if it ends up that the p-value, we're like, you know what, that p-value is so small, it's so unlikely that this would have happened, we're going to reject H sub O. What do we conclude? You actually conclude H sub A in context. Now, what if you fail to reject H sub O? What do you conclude? If you say, you know what, that p-value is not bad. I can't reject H sub O. I'm going to have to fail to reject H sub O. Here's where you have to be very, very careful. Really, if you fail to reject H sub O, then you can't conclude H sub A, right? We're not going to come back and say, well, we failed to reject it, we conclude H sub A. Of course not. That doesn't make sense. But what you can't also do is you cannot, and be very careful with this, conclude H sub O is true. So how do you have to say it? Let me tell you the proper way to make your conclusions. And here is the ultimate guide. Here's the first one again. Our p-value is small. If that's the case, p-value is small, we're going to come on in and we're going to reject H sub O. And if we reject H sub O, we therefore conclude H sub A, and we're going to put it in context of the problem. Fine. What if the p-value is large? Well, if the p-value is large, we fail to reject H sub O, and here's your conclusion. You cannot conclude H sub A in context, is all you can say. So up here, what I have written in the red are your actual conclusions. Again, careful, never ever say you conclude H sub O is true. So in the criminal trial case, there's two conclusions you could make in this case. If you find that the p-value is small, we would say, okay, p-value is small, therefore I'm going to reject H sub O and conclude guilt. So reject H sub O, conclude guilt. But if the p-value is big enough, how you have to say it is you fail to reject H sub O, and I cannot say the person's guilty. So you actually take the converse of this, that you're not guilty, is all you can say. You cannot come back and say the person's innocent, because the first reason they're in the courtroom right now is because there's a suspicion of guilt. Practice the conclusions. Here we have, again, we're back to the basketball scenario. We know this p-value by now, right? 0.75%. We know our hypothesis that we stated and our alternative hypothesis. So what conclusion do we make? Well, this p-value here is small. So in a formal way, here's what I would say. We're always going to start off and talk about the p-value. In this case, I'm going to say the p-value is small. So what do? I reject H sub O. Therefore, I conclude the player appears to make less than 80% of his shots. And that's how you would state this. Let's look at the golf example. Now, let's say the p-value actually wasn't this small, but it was actually pretty big. What if it came in at 0.15 or 15%? How would you adjust this? Well, here's what you'd say. Well, the p-value is large, so I failed to reject H sub O, and we cannot conclude the player appears to make less than 80% of his shots. So on here, it is very similar to the other one, except here I said I fail to reject H sub O, and I cannot conclude what H sub A is in its context. So let's look at our golfing example. Remember, this was our hypothesis for our golfing example. We think standard deviation is less than 15. The p-value that came back is right here at 0.002. What is our conclusion? Well, based on that, we can see that the p-value is small, so we do reject H sub O, and what do we conclude? We just conclude this statement here, so look right back at it and just say this. We conclude sigma of new clubs is less than 15, and Mike is more consistent using his new iron. The easiest way to state this blue portion in context is to literally just go right back up to the alternative hypothesis and put it in words as it relates to your problem. Now, let's talk about, when is the p-value too small and too big? I need to kind of have a reference point for that. And we do. It's called the significance level. So we are going to define a significance level. What do we think a big P versus a small p means? So we're going to compare the p-value with a fixed value we regard as decisive. It's usually 1%, 10%. More commonly, they choose 5% as the p-value. And it is typically referred to in our Greek letters as the alpha symbol. So what it is, significance level is the fixed value alpha with which we compare the p. Again, typically how you're going to see this written is you're going to see it says alpha is equal to 0.05, which means this is what we look at to compare our p-value with to decide if it's too small or too big. All right, what is statistically significant? If the p-value is smaller than alpha, we say that the data are statistically significant. So go back to the p-value when we saw like 0.002. All we would do is say, is this p-value smaller than this alpha? If it is, in this case it is, we would say the results are statistically significant. So when p-value is smaller than alpha, we reject H sub O and we conclude H sub A. Again, if the p-value that we compute is bigger than alpha, what would we do? We would fail to reject H sub O, and we cannot conclude H sub A. Look at one final example called Tasty Chips. So for his second semester project in AP Stats, Zenon decided to investigate if students at his school prefer name brand potato chips to generic. He randomly selected 50 students and had each try both types of chips in random order. Overall, 34 out of 50 preferred the brand name chips. Zenon preferred a significance test using this following hypothesis. Okay, his H sub O. The true population proportion is 50%. He believes it's going to be higher than 50%. Now, be careful, what the heck is he even talking about P? You do have to define it. So he defined P as the true proportion of students at his school that prefer the brand name chips. So he thinks more people than not prefer brand name chips. Okay, he did his test. The resulting p-value that he got for this test was 0.0055. What conclusions can he make based on the following significance levels? So if alpha was set at 0.01, which is 1%, what could he say? Here's how he would make his conclusion. And this is going to be in 3 parts, which you now want to make sure all your conclusions have these 3 components. First thing he's going to say, since P is less than alpha, you must show the numerical comparison here. P is less than alpha. That's step 1. What do we do now? Because p is less than alpha, we reject h sub o. That's the second thing. Because we reject h sub o, now what? We conclude that the students at Zenon's school prefer brand name chips, which is basically we accept h sub a in our final conclusion. Okay, let's flip it. What if alpha was 0.001? Okay, well this clearly is bigger than alpha, so only twist would be this. We're going to say the three parts again. The first is, since p is greater than alpha, you have to show that calculation that p is greater than alpha. Now what do we do? Well, second thing, we fail to reject h sub o. You have to pick one of them. Now your final conclusion, we cannot conclude that students at Zenon's school prefer brand name chips. Again, all three components must be talked about in your conclusion, otherwise you will lose points. This AP tip right here is exactly what I just said. You have to talk about your comparison of the p-values to significance, you make your decision to reject or fail to reject, and you make your final conclusion. So just be careful to do that going forward. The last question here, though, says, what should be considered when choosing a significance level? You know, a few things just to keep in the back of your mind. The first is, how plausible is your h sub o? Does it seem somewhat reasonable to happen or not? And you also are going to want to think about, what are the consequences if you were to reject your h sub o based on the alpha that you choose? Because the alpha that you pick it, basically. Again, the most common alpha to pick is 5%. But there's no rule that says I can't choose 1% or 10% for this. We will talk about the consequences of this in a different video.